So now let us look at the case where I have an inclined plane. We have already seen what happens if there was a force like this, right? You have mg sine theta, you have mg cos theta, you have n, and you have an extra force. Now we also saw what happens if there is an extra force that was in the perpendicular direction. But it need not be like this, it need not be like this, no? It can be like this. Then what do? Then you will say, let me resolve this force in this direction and this direction. You can't use alpha because f cos alpha will give me horizontal, but you can find what this angle is. So if I think of this angle and think of it as beta, you can say f cos beta, f sin beta. Then you know that this force is an extra force that we have to use. Now this looks very complicated. Okay, let us take an easier example and try this out. So here I have a 10 kg block on a smooth incline. Angle of the incline is 37 degrees and there is a horizontal force of 40 newtons. Okay, let us find the acceleration and the normal force. You know that there is a gravitational force. Just to make life easy, I will start with the gravitational force pointing down like this, though it is supposed to start from the center. Okay, you know that this component, how much is this? This is 100. Why 10 into 10, 100, right? So this is mg sine 37. So it is 100 into sine 37 is 3 by 5. Look at this. This is 20 into 3, 60 newtons. And what about this component of the force? mg cos 37, which will be 100 into 4 by 5. And you can see that that is 80 newtons. I will get rid of this. Now there is an n. And don't assume n is equal to mg cos theta. It is not mg cos theta. Now I've got this force, I've got this force, I've got that force, and I've got a 40 Newton force. Now let us see. Now if there are two lines that are parallel and you have something like this, you know that if this angle is something x, this angle and this angle are equal. Alternate angles, right? So if this angle is 37, look at this. This is a parallel line. So what is this angle? 37 degrees. So if this is 37 degrees, this is 37 degrees. If there is a force like this force you can resolve like this. If this is F, this component of the force will be F cos 37 pointing upwards. It's an arrow, so it is pointing upwards. And then this will be F sin 37. Now you have to learn how to resolve forces very carefully. So, okay, so F cos 37, F sin 37, 40 will become 40. Look at the direction is upwards. 40, this is 37 degrees. Okay, I'm not marking it, this is 37 degrees. So 40 cos 37. Remember F cos theta. 40 cos 37. What is 40 cos 37? Cos 37, remember, is 4 by 5. So 40 into 4 by 5. And then this force will be 40 sin 37. So 40 into 3 by 5. I don't have the 40 anymore. Okay, so there is this force, there is this force, this force, this force, so many forces. Very confusing. But you know that this direction, they are independent. Okay, so in this direction, do you think this block is going to fly away? No, right? In this direction, what is the acceleration? 0. So in this direction, acceleration is 0. So let us write net force is mass into acceleration. Mass into acceleration is 0. In that direction, n minus 80. I'll only count this force and this force. These two are perpendicular direction, not affecting. Only these three will affect this direction. N minus 80 minus this fellow. How much is this? 8 into 3, 24. So minus 24. Is that okay? So how much is N? 104 newtons. Right? And if I come to this direction, let us write mass into acceleration ma. I have taken a to be downwards, like this. Okay. Now what about this? This and this, notice, are both along the incline. This and that are all perpendicular to the incline. So along the incline, how much is this? 8 into 4, 32. Right? 60 like this, 32 like that. 10a is downwards. So 60 minus 32. Is that okay? 60 this way, 32 that way. 60 minus 32 is the net force in this direction. Must be mass into acceleration. How much is this? 28. So 28 by 10 must be A, which is 2.8 meters per second square. What is the acceleration in this direction? 2.8 meters per second square. What is the acceleration in that direction? 0. What is the overall acceleration? 2.8 meters per second square. So I only need to find this to find acceleration. Question asks me to find A and N. For A, the answer is 2.8, and for N, the answer is 104 newtons. So I hope that is clear. This is a little bit difficult question, right? But keep in mind that for any kind of a question, quickly resolve mg cos theta, mg cos theta, mg sin theta. Along the incline, mg sin theta. Perpendicular to the incline, mg cos theta. If there are other forces, then you will have to worry about how to resolve them. For n, you don't have to resolve n. N is already perpendicular to the incline. You have to resolve mg, you have to resolve any other force that you need to deal with. Okay, I know that many of you would have found this particular question a little hard, because not only does it have resolution of mg, it also has this additional force, right? This force that we had to basically resolve, right? If you did that, then obviously the question gets a little bit more tricky. But don't worry about it. What you will find is, as you start to learn how to resolve forces, you will find it becomes quite straightforward. Very simple. Instead of using xy axis, all we are doing is to use the inclined plane itself as one axis and the perpendicular to the incline as the second axis. So any other force that you are getting must be resolved in this direction or in that direction. That's all we are doing. It will take a little bit of getting used to. It is not difficult. It is something that you just need to get used to. So try out a few problems. You will find that it becomes quite easy.